This next little part, we're going to talk a little bit about cholesterol. Now, cholesterol is not a triglyceride. It's not actually a fat or oil, but it is closely related. So I want to show you the difference in the structure and then talk a little bit about cholesterol and your diet. So here we have cholesterol. Now, cholesterol is present in virtually all animal cells. So that's something to keep in mind, virtually all animal cells. And its cholesterol is an example of what we call a steroidal alcohol. It's based on a basic structure called a sterol. So here's the sterols up here. We have 3 rings of 6 carbons and then 1 ring of 5 carbons. Now what you can do is you can change like what side groups are on there and if there's any double bonds, and you can change this basic sterol into all sorts of different compounds. And that's what we've done with cholesterol. So here is our cholesterol. So we have the same basic structure. There's 3 different rings with 6 carbons. And then we have our ring of 5 carbons that's attached. But you can see it has very specific side groups that have been added to this. So let's learn some more. We're going to talk specifically about what's called serum cholesterol, or the cholesterol present in your blood. So if you go and have your blood drawn, they'll tell you what your cholesterol levels are. Do you know what the borderline level is? What do you not want it above? Well, generally you don't want it above about 200. 200 to 239 is considered to be borderline, and then it gets high, and then you start making modifications to make sure that you stay healthy. Now, when they say 200, that means that it's 200 milligrams of this serum cholesterol, this cholesterol, for every 100 milliliters of blood that's pulled out. So they can look to see the relative amounts, the concentration of that cholesterol in your blood. Now, if you have really high levels of cholesterol, that's associated with atherosclerosis. See, I even stumble over some of these words, or just hardening of the arteries. So what will happen is that there's a stiffening and a thickening of the walls of your arteries, which leads to high blood pressure and also can lead to heart disease. Now, cholesterol is present in 2 different ways. It's present in your diet, so it depends on what you eat, but it's also manufactured by your body. So sometimes, no matter how clean of a diet you have, you can still have issues, and I'll give you an example of that. But first, let's look over at this picture. So on this picture, we have the idea of an artery, and of course, blood's flowing through here. But what will happen is that cholesterol will start to build up. So here we're trying to show within the artery walls, the cholesterol is attracted to the wall of the artery, and it doesn't necessarily flow really good with the blood. Now, cholesterol and fat and other blood components, some of them tend to be hydrophobic, meaning that they don't really care for water. They're a water hater, but they like the sides of the walls of the arteries. And if a little bit sticks on there, then the next ones that come along, they're likely to go ahead and stick to those ones that are already starting to be there. Now, what happens if we completely close off this area where this thickening goes across the whole artery? Well, we're not just restricting the blood flow, we can actually almost stop the blood flow, and that's not good. That's when we start seeing heart attacks and strokes and a bunch of other things. Now again, part of this is your diet and part of it is genetic. My husband has very high cholesterol. It's a genetic thing. So what he actually had to have done is they went in and they put a stent in here. So they went in and they actually forced this opening to be bigger by putting in stents like this little small metallic or a polymer piece, depending on what kind you get, and it'll actually increase just a little bit to allow that blood to have room to be able to flow through there. Now, another thing with that serum cholesterol, sometimes they'll break it apart into your HDL and your LDL, your HDL and LDL, and that's high density lipid and a low density lipid. The HDL is the part that transports cholesterol to the liver. And so we like the HDL. The LDL is what transports the cholesterol to your artery walls. So we don't like that one quite as much. So anyway, a little bit about cholesterol levels for you. If your cholesterol does get to be borderline, the first thing the doctor will recommend is, well, let's try watching your diet. Now, cholesterol is in all animal tissues. So if you eat any animal products, you're actually ingesting cholesterol with that diet. Now, there's different levels. So you have things that are very high levels of cholesterol, including egg yolks, red meat, animal organs, like liver. Liver is very, very high in cholesterol. It's really good if you're getting ready to donate blood because it has large amounts of iron also, but it does have lots of cholesterol. Cream, butter, and your cheeses. Your low cholesterol foods include egg whites. So a lot of times that's one recommendation that they'll make is, like, if you're eating your breakfast and you want an omelet, have an egg white omelet instead of a whole egg omelet. Yogurt or a fat-free milk. And then we have some things that have no cholesterol, such as fruits, vegetables, vegetable oil. If you notice, they're non-animal products. Cholesterol and fat are closely related, but they're not the same thing. And the foods that have these items, if they're high in one, they may or may not be high in the other. So what this particular slide is looking at is, over on the left, we have different levels of cholesterol. On the right, we're trying to show the different types of fats, and it breaks it down again between saturated, mono, and polyunsaturated. So if you notice, butter is high in cholesterol and in your fats. If you drop down to margarine, here's margarine way down here, because margarine is actually considered to be a vegetable product. It does not have any cholesterol, but you still have very high levels of fat. Now the different amounts of that, percentages of your poly, mono, and saturated fats are different, but it still has a lot of fat. If you notice some of your meat products, especially eggs, eggs are kind of an unusual thing, and one thing that I have learned, and I guess just to impress upon you, is as we find out more information, sometimes recommendations will change. So when I was growing up, eggs were the devil. You should never ever eat eggs. Margarine was good, butter is bad. Well, then it comes out eggs aren't the devil anymore. They're not that bad. Eggs are good for you, so you should always eat eggs. So you have something that still has some fat, not as much as some other things, but you have a lot of cholesterol. So is it good or is it bad? Personally, I believe everything in moderation. Just can't go to extremes on everything. Should you use butter, which is a more natural product, but does have large amounts of cholesterol and fat, or should you stick with margarine, which is a little more, we'll say, processed, but you don't have any cholesterol? Again, everything in moderation. I personally love butter, but it just kind of depends. You'll have to use your best judgment. Again, so there's somewhat of a correlation between the two, but it's not the same. Cholesterol is only in animal products. Not only is cholesterol in our diets and the food that we take in, cholesterol is also manufactured by our bodies. And so this is kind of what my husband's having to deal with, is genetics. He really has no control over it. Our bodies make it. Now, I say that we don't have any control over. There's a certain amount we don't. It's out of our hands. But you can influence other parts. For instance, the amount of exercise. If you exercise a reasonable amount, it can help. Emotional stress, we want to try to reduce the stress, and you'll actually see differences in cholesterol levels based on that. Now, your diet does prove to be kind of a double-pronged type thing. If we eat foods that have a lot of saturated fats, which generally means that they're going to have some cholesterol, generally, not always, our liver actually makes more cholesterol. So if you are eating a really high fat diet, not only are you getting the cholesterol from those foods, again, generally depending on the foods, your body actually goes into almost like overdrive trying to produce this cholesterol. Essential fatty acids are those that our bodies can't produce. These are different molecules that we have to have in our diet because, again, our body just can't produce those, but we need them. Omega-3 fatty acid is an example. So down here we have the structure. This is DHA. So if you ever look at baby formula, sometimes they'll talk about adding DHA to that. Because this is one of those fatty acids, again, that's got to come into our diet. This is something that is in salmon and some other fish products. So they talk about how salmon's healthy for you. It's because of this fatty acid. This one has been known to help lower heart disease. So it's a good thing to have. Now, the reason that we call it an omega-3, this is kind of interesting. So do you know what omega means? Omega is a Greek letter. So maybe you've heard of the alpha and the omega. Alpha is the first letter and omega is the last letter. It's the beginning and the end. So normally when we're looking at a molecule and we're trying to count the carbons, we generally start by counting the carbons from like the biggest functional group. So on this one, we would actually start over here. We'd say, okay, this is carbon 1, carbon 2, carbon 3, 4, 5, 6, and then we would keep going. But if we're looking at omega, instead of counting from the beginning, we count from the end. So we would actually start at the end of that chain and count backwards. And usually what they'll do is they'll count until they reach a double bond, because those double bonds are special and we have to make note of where those double bonds are. So the first double bond comes out of 1, 2, 3. That is an omega-3. So if you had an omega-6, that means that you would count back to that 6th carbon, and that's where you would have the first double bond. So that is what omegas are.